This is AP Calculus AB. We are on worksheet 11-1, area under two curves. Let's begin. In number one, we're trying to find the area of S, as always. I don't really read all of this stuff for this homework, but if you're ever confused which area you're trying to find, was I trying to find that one or that one, maybe you do need to read, but it's pretty clear. Find the area of S, so I'm going to stop explaining that and go. All right, so I noticed that there's a curve right here. I'm going to find the area of that piece, and a curve right here. I'm going to find the area of that piece. So that means I'm splitting this down the center right here. I need to find what is that x coordinate. So I go to my graphing calculator, type in y equal to, and I'm going to say, okay, I have the function y equals x, and I have the function cosine of x, And my window for this, let's go ahead and clear out all these things. My x minimum, and this one, I'm just going to literally enter whatever I see on the graph. X goes from 0 to about 2-ish, so 0 to about 2-ish. And then my y minimum goes from about 0 to about 1-ish. So I can just come down here and put 1-ish and then hit graph. And I get this graph that looks kind of similar. Let's go ahead and clear out of all of these things. So in order to find this intersection, I'm going to do second trace to do a calculation of intersect. So I'm going to hit option 5. And my calculator might be a little bit different than yours. It's asking, my prompt is, what's my left bound? I'm just going to enter 0. My right bound, I'm just going to enter 2. And I get an intersection of, let's zoom in here. This is going to be 0.739. I don't know how to write here. 739. All right. So I found my intersection, and now I'm ready to set up my pieces, because again, I'm always going to be doing integral of the left plus the integral of the right. So the integral of the left, S is going to be equal to, the integral of the left is going to be the integral between 0 and that suspect point, that 0.739 of my left function. This left function is this one right here, which corresponds to y equals x. I'm just going to type or write in an x, dx, if I'm being formal about that. And then I'm also going to add the right piece. The right piece goes from the same bound of 0.739 all the way to, come on, move over, that spot right there. And okay, so this is one of those things that if you know your trigonometry, this goes really fast. I happen to know that cosine of pi over 2 is 0, because pi over 2, really quickly, here, let me write this down. If I have this is 0, this is pi over 2, this would be pi, right? Pi over 2 lives right up here, and if I do cosine is talking about the x coordinate, going right or going left. When do I have 0 right or left? At this point. So pi over 2 will make me go to 0. So I know that this point happens to be pi over 2, but let's say you didn't know your trigonometry. How would you have found that point anyway? Well, you'd come up here to your window, and I'm changing my y minimum to -1. So I'm going to change you to -1, and we'll regraph you. And now if I do a second trace and I want to find a 0, I'd hit 2. My left bound would be 1.2, and my right bound would be 2, I suppose. And I get this 0 of, and it's telling me, I'll write this up above, 1.571, because it's technically 0, right? But I'm going to round it to a 1. And let me just double check. Is that pi over 2? So I'm going to hit second pi, which is the power symbol, divided by 2. Is pi over 2 the same thing as 1.571? It is indeed the same point. Okay, so that just brings us down here to say the upper bound is, if you want to be really fancy, you can say pi over 2. But I have a feeling that most people don't have their trigonometry mastered as cool as Mr. Sindel does. So you're going to enter in a 1.571. And then the function that goes in here is cosine of x dx. And then you just got to type this all into your calculator. If you want to do it all at the same time like I do, cool. Math 9 is going to be 0 to, oh my God. Come on. Math 9, 0 to 0 point, I cannot type to save my life, 0.739. In my defense, typing on this digital keyboard with no tactile feedback is a little bit hard. Plus math 9 of 0.739. You don't have to have the 0. I was just being stylish. 1.571 of cosine of x. And invalid variable. Why are we invalid? That's super strange. What? What if I just go and do this all one step at a time? Apparently my calculator can't handle my genius math abilities. So 0 to 0.739 of just x. Well, can you handle u? Okay, well, it handled that one okay. I'm going to write this one down. That one is 0.273. And then I'm going to do math 9, integral between 0.739 and 1.571 of cosine of x. Cosine of x. Is that we're just going to... It liked that one for whatever reason. What did I type in wrong in the last one? I don't understand. It's going to be 0.326. And adding those together, I have a calculator, so I'm just going to do it for me. 0.273. I get 0.599. So I have a feeling that's probably 0.600. But I'm going to write down 0.599. If you got 0.600, I'm going to write down 0.599 or 0.600. Both of those are acceptable. I'm going to go ahead and box both of them. All right. Number 2. We got the 2 graphs. Find the area below. It's pretty clear. I'm going to go ahead and cut this one in half right here. I don't know where that's happening, so this is a big question mark. I don't know where that one is happening either. Let's go ahead and find both of those. First, let's do the intersection. So I need to come back here and go to my y equals to, and I'm going to say my first function here is going to be tangent of x, tangent of x. My second function is going to be 2 minus x cubed, x to the power of 3. Very good. My bounds are going to be a little bit rough. If you don't know your bounds, good bounds, typically in all graphs that I've seen, they don't really go past 10. So my x max, I'm going to change you to a 10. And I'm just going to, I know that my y minimum can't be anything less, or it should be 0, I guess. I'll leave it at -1, and we'll change the y max. I'm just going to guess here 10. And I'm hit graph instead of zoom 0. And whew, yeah, it was really over there. My x max, I can change you to a 2. I'm going to come back here to my window, change my x max to a 2. And I'm going to graph that one again. Nice. I can change my y max also to a 4 if I want to zoom in there. Do I want to? Sure. I'll zoom in here to x max of 3 actually, or y max of 3. Y max of 3, and then I'll graph you. Oh yeah, looks beautiful. All right, so to find the intersection, I'm going to do second trace to do a calculation of the intersect. So I'm going to hit 5, and my left bound, sure, 0.8, why not? Right bound, 1.6, sure. And that intersection happens at the x coordinate. I'm going to write this down in my notes as well. It's going to be 0.902, 902. And then I need to find the next x-intercept over here. And my calculator is so smart that it already found the x-intercept. It says the 0 happens at 1.2599. If you don't know how to do that, here, let's pretend I didn't know that. I would hit second trace, and then I would type in 0, so I'd do 2. And my left bound would be 0.8. And my right bound, again, sure, 1.6. It doesn't matter, sure. And it says, okay, yeah, the 0 is clearly, and I'm going to write this down. This point right here, oops, I want to do this in pen though. That, maybe I'll do it underneath. This x-intercept right here, that 0 is 1.2, I will say 599, but that rounds up to 260. Okay, and technically that's the cube root of 2. I can just tell by plugging it in up here, but that's okay. So from here, let's go ahead and set up our integrals. It's always integral of left plus integral of right. The integral, we'll say r here. R here is equal to the integral of the left, which is going to be integral from 0 to 0.902, 0 to 0.902 of our left function. Okay, so this is bounded by this curve, and that curve corresponds to tangent of x. So we're going to say tangent of x dx plus, and then we're going to do the integral of the right piece. So come on, move over, thank you. The integral from that same 0.902 to the right piece, which is 1.260 of this function over here. So you can clearly see that the top here is right there. It's corresponding to that function, 2 minus x cubed, 2 minus x cubed. Technically, all of that needs to be in parentheses, dx. And we just, can I put this all in the calculator at the same time, please? You're supposed to be able to. It's going to be, if it doesn't work the second time, I'm just going to do them one by one from here on out. So please work, clear out of everything. Here we go. So this is going to be math 9 integral between 0 and 0.902 of tangent of x. Okay, everything there is good. And I'm as far to the right as possible. I'm going to do plus math 9 integral from 0.902 all the way to 1.26. You don't need the 0. And then it's going to be 2 minus x to the power of 3. Please, please, please work. Enter. Hey, it worked all at the same time like it's supposed to, which is equal to 0.729 in boxes. All right, moving on to the next problem. All right, what do we see here? We're trying to find S, and okay, so this one is interesting, not just because it's the first problem that's shaded. Typically they are shaded if it's kind of hard to tell which what you're talking about, but it's also different that I don't know which function goes to which. I'm so confused. Well, check this out. 2 to the power of x always looks like this, or like this, or like this, or like that one right there. Something that has a minus x squared will always be a sad face or a rainbow, depending on your personality that day. Are you a positive person? Or are you a negative person? So I have a negative x squared, so that's clearly this one. So in this one, I need to label this piece right here is my, what did I say, 3 minus x squared. 3 minus x squared is this function right here, and that means my 2 to the power of x is this function right there. Okay, so from here, where am I going to have my division? It's going to happen right at that point. Draw a vertical line straight down. I need to figure out, that's clearly 0, but I need to figure out what is that point and what is that point. And I have a calculator. Do I have a calculator for all these problems? Ooh, suddenly I don't have a calculator, so I do need to pay attention to that. I do have a calculator, so let's just go ahead and tell the calculator to find those values. And what do we got here? Set up what we have so far, S. S is going to be equal to the integral of the left. So it's going to be between 0 and a value that we don't know of the function. What's the function on the top? The function on the top right here for that area is 2 to the power of x. So we're going to put in 2 to the power of x and then dx plus the integral from a value that we don't know to another value that we don't know of our next function, which is 3 minus x squared, that quantity dx. We just need to find some bounds now. So let's go ahead and find this intersection, and we'll find that 0. So let's come to our y equal. Let's clear out of both these functions. Our two functions are going to be 2 to the power of x, 2 to the power of x, and 3 minus x squared. So far, so good. What should we do for a window? I'm not sure. Let's say a window. It's only talking about that right piece. So I know my x min is still 0. I think my x max is probably going to be around, probably less than 3, right? Oh, it might be 9. Think about this, just logically. Oh, it can't be 9. So if it's 9 squared, that'll be 18. That'll be something like, I think square root of 3 would be the answer here. And square root of 3 is a little bit smaller than square root of 4, which is 2. So I think 2 is fine. And my y minimum, sure, -1. My y maximum, I kind of want it to be a bit higher, just in case. I'm going to change it to a 5. I just got a gut intuition. If you're not sure, make it too big. Let's try that graph. Oh, man, Mr. Sindel, you are on fire. Good. Okay, so wait, does that look correct? Okay, it does look correct. It's just scaled kind of weirdly. So I need to find the intersection of the blue and red lines. I'm going to hit, not alpha, but second trace to do a calculation of an intersection. So 5. Left bound is going to be 0.4. Right bound, I don't know, just 2. And it gives me a bunch of information. The intersection happened at a really nice point. It happened at x is equal to 1. Lucky us. So that happened at 1.000 on the dot. And then this intersection right here, my calculator is so smart. It does it for me. I'm going to go ahead and run through it again because I don't think your calculator does that. And I think the way that I'm doing my calculator, my prompts are different than your prompts. But let's go ahead and do this again. So let's clear out of all this. Let's do second trace, and we'll do a 0. So I'll hit 2. And I'm trying to find that it's about 1.7-ish. So I'm going to say my left bound is 1.6. My right bound, let's do 2. And we get 1.732. 732. So we have our bounds now. Let's go ahead and put them in here. This goes from 0 to 1, and then 1 to 1.732. Okay, so we can just type all that into our calculator, our left integral plus our right integral, and we are done. So it's going to be math 9, 0 to 1 of the first function, which is 2 to the power of x. Go all the way to the right. Maybe I was like inside, like if I go left there, maybe that's what it was, the error. I'm not sure what it was. So plus math 9, the integral from 1 to 1.732 of the next function, which is 3 minus x squared. And then let's see, ready, set, go. 2.24. All right, very nice. It technically had a 0 at the very end of it, so this is 2.240 to show that I'm rounding to 3 decimal places, and box it. Very nice, very nice. Moving on to the next problem. This one I cannot use a calculator, so hide that thing. All right, how do I do this without a calculator? Okay, so yet again, it tells us f of x is square root of x. So if I want to, I could say, okay, technically that's the square root of x right there. This is equal to 6 minus x over here, and we're trying to find r. Well, r very clearly, it looks like it's exactly above 4, but probably the case. Let's go ahead and it's in the notes, but I'm not going to write it now. I'm out loud telling you I'm verifying that this x coordinate is 4 by setting this equation equal to that equation. So square root of x, let's set that equal to 6 minus x. And in order to, this is kind of tricky to verify, but you don't really need to because it looks so good. But let's go ahead and say, okay, square that side. Let's square that side. I square that side. Therefore, this side is equal to x, and this side is equal to, this is tricky, be careful. This is the same thing as 6 minus x times 6 minus x. And if you do 6 times 6, you get 36. If you do 6 times negative x, you get negative 6x. And maybe I should be writing out my work. I just did that. Now I'm going to do this one. Negative x times 6 is another negative 6x. And then this negative x times negative x is a positive x squared. Most students will forget those middle terms, and that is a sin. You cannot do that. You cannot forget your middle terms when you have a perfect square. So now I have this fancy equation that says x is equal to 36 minus 12x plus x squared. Side note, you might know the formula to expand this immediately whenever you have a perfect square. It's the one that rocks your baby to sleep. Square the first, double the product. The product of negative x and 6 is negative 6x. And you double the product, so you get negative 12x, and then you square the last. So square the first, double the product, square the last. That will always rock your baby to sleep. It will put your baby to sleep, and it will also expand their squares. Anyway, let's go ahead and keep moving this thing forward. Can I move this x over here? I can, so this is going to become 0. Let's change the color here. This is going to be 0 is equal to 36 minus 11x plus x squared. And now the question is, what is the ninja star equivalent of this? What things multiply to 36 and at the same time add to negative 11? And hint, probably the answer is going to be 4. Or that means I have a negative 4 out of this. So I'm going to somehow guess here. We get an x minus 4. So if I get a minus 4, that means I need a plus 8. That doesn't work, though, does it? Because then I get a 12. Tricky. Does this actually work? Do I even need to be doing this? It seems like a lot of extra work to not get the right answer. I'm checking all the factors of 36. 36 could be 2 and 18. It could be 1 and 36. It could be 3 and 12. I'm trying to make sure somehow get these two numbers to get to 11, and they're not working. Did I make some mistake? I made a mistake. There it is. When I subtracted the x on this side, and I subtracted the x on this side, I said negative 12 minus 1 is negative 11. It's negative 13. Negative 13. And if I do that, does that help me? Still doesn't help me because none of these somehow get to a 13. 3 and 12 still don't get to a 13. Keep going though. 4 and 8 don't get to a 13. 5 doesn't go into it. 6 does go into it, but we already did 6 and 7. And yeah, I don't understand. Why did this not work? I'm going to probably ignore that and come back to it, but I'm really frustrated why this didn't factor out as a 4. Thinking. Did I randomly mess up in my equations? 6 minus x and x, those worked out. It should be a 4. Is there some sort of mistake? Well, you can just plug in a 4. They should work, right? If you plug in a 4 here, the square root of 4 is 2, so it gets the height of 2. Plug in a 4 here, or sorry, 4 here, 6 minus 4 is 2. It should have worked. Why did it not work? This is the way that you would solve it. Square root of x is equal to 6 minus x. You square that, square the first double x, square the last, and then you just move this x on over. I'm very confused. And I'm just not factoring this thing right. Here, I have a second computer open. Let me go ahead and, if I go to Wolfram Alpha, and I type in this equation, am I just being silly? X squared minus 13x plus 36. What does it give me? Oh my God. Mr. Sindel. Mr. Sindel. Why? 4 times 8 is 32. Is that 32? No. Do you know what that number needs to be? 9. Okay. So, it was staring me at the face. X minus 9. It happens. I look at that time. It's 11:19. It's late. That's what I'm blaming it on. I'm sorry. Okay, this is x is equal to 4, or x is equal to 9. And hey, look, that's one of the solutions. It's x is equal to 4, and it's x equal to 4. I verified that it is indeed one of the bounds. Okay. Did I need to do all of that? Did I need to spend 10 minutes of my life frustrated that I couldn't solve a problem? No, but I feel smarter that I memorized my times table a little bit better, that 9 times 4 is 36, so there's that. Anyway, we have capital R is equal to the integral of the left plus the integral of the right. The integral of the left is 0 to 4. I know that in my heart now, that it is true. 0 to 4 of that square root of x function, square root of x dx, plus the integral from 4 to 6 of that other function, which is 6 minus x. So the quantity of 6 minus x dx. And I don't have a calculator for this, so try to find some shortcuts here. So the shortcut that I'm seeing here is, I have a dashed line feature. So I'm going to go and make a dashed line right there, right about there, and dashed line right about there. And I can see that this is a square that is, whoa, not with a dashed line. This is a square that is 2 by 2. I think it's 2 by 2. Yeah, it goes up 2, right 1, 2. Therefore, the entire area of the square is 4, but it's half of the square, so this area down here is a 2 without a dashed line, please. So this area here is a 2, and I just need to find the area over here, and then I'm done. So I'm going to come here and say, this area right here, cross you are a 2, and I just need to do the antiderivative of x, and we are good to go. What do we got here? Okay, so do I need to pay the tax person? You have a derivative of 1. We are allowed to bypass the tax person. So this is going to be, technically it's x to the 1/2. Just as a reminder, on the side note, square root of x is the same thing as x to the 1/2. That's the knowledge that I'm using here. Therefore, if I'm paying tax person, this power is going to go up from 1/2 to 3/2. This is going to be x to the power of 3/2, and then divide by 3/2, or multiply by 2/3. Evaluation bar between 0 and 4, and we get something. What do we get? I'm gonna ignore the 2 and get you at the very end. So this is going to be 2/3 of x has turned into a 4, and that's to the power of 3/2, minus, and I'm going to do 2/3 of 0 to the power of 3/2. And I don't know if you've heard the news lately, but 0 to any power is 0. I don't care if it's a fractional power. And 0 times 2/3 is still 0, which means this whole thing goes away. It's all 0. Unfortunately, you still need to figure out what that is. How do you do 4 to the power of 3/2? Well, I'm glad you asked. 4 to the power of 3/2 is the same thing as 4 to the power of 1/2 to the power of 3. How did I know that? Because 3 times 1/2 is 3/2, and a power to a power you multiply. Did you also know that 4 to the power of 1/2 is the square root of 4? Which means this is really 2 to the power of 3. And did you know that 2 to the power of 3 is 8? I did. So this whole thing is really 8, but there's 2/3 in front of it. So 2/3 of 8, let me put a little multiplication symbol. 2/3 of 8 is 2 times 8, which is 16, 16 thirds. So this is 16 thirds, and that's really, really close to 15 thirds, which is 5 1/3. Do I care about fraction on this one? I kind of prefer decimals because that's the calculator answer, right? This is the same thing as 15 thirds plus 1/3, which is equal to 15.333 if I'm running to 3 decimal places. And don't forget your plus 2. Plus 2. This plus 2 came over here, right? And therefore our answer is 17.333. 17.333 units squared if I'm being cool, but I'm just going to stick with 17.333. I need to go back to my answer key and make sure I'm doing an okay job. Oh, Mr. Sindel, last year you did fractions. I think that's right. Yeah, that's right. If you stuck with fractions because you're even cooler than Mr. Sindel, you could have also said 22 thirds. 22 thirds. That's also okay. All right. What am I feeling now? There's a part B on this one, still with no calculator. Give me back my tool. There is a point P on the graph of f at which the tangent line, oh my God, there's a tangent line to the graph of f is perpendicular to the graph of g. It's not even tangent, it's perpendicular. Find the coordinates of point P. Oh my goodness, what is going on? Let's draw a picture. So, it's perpendicular to g. So, that's kind of easy because it's not talking about this curvy thing f. It's talking about g. So on g, we know we are perpendicular. Perpendicular means 90-degree angle. If you failed geometry, I have now refreshed your memory. So from here, I know that I have a slope that is the opposite reciprocal. How did I know that? I'm just a genius that I know that the word perpendicular means if I had a slope of, I'm just making this up. This is a made up example. If I had a slope of 1/3, which we clearly don't have, this slope was negative for our case. But if I did have a slope of 1/3, then to be perpendicular would be -3/1. You flip it, so it turned into 3/1, and you make it negative. A negative flip means perpendicular. So how do we change that? And maybe instead of writing that in my notes, I don't want to confuse people that are looking at the static answer key. Let me just say perpendicular means a negative flip of the slope. So what is our slope? Well, our equation is 6 minus x. It's kind of a dead giveaway that it's a negative something, -1x. So our slope here is -1. If you didn't believe me, it goes down 1, right 1, down 1, right 1. That is a definition of a slope of -1. So if you flip 1, it's still 1. Check it out. 1/1. 1/1. I flipped it. Crazy, right? Okay. Now, I'm going to make it negative, and I've found the slope. So I'll say, not our slope, I'll say slope of, and we're talking about f or g? It's f, right? That's g. Tangent to the graph of f, perpendicular to the graph of g. Oh, hold on. What's going on here? It's perpendicular to the graph of g. So slope of g, let me make sure I write this right. Slope of g is -1. Perpendicular slope is +1. So we now know the slope. And we need the line tangent to the graph. So line tangent to the graph, to me, means it's some sort of blank minus blank. I don't know if that's going to help me. Oh, it's one of those where you gotta, here. Okay, so first of all, we know this. I'm going to say it's always going to be y minus box is equal to box times x minus box. Why do I think we need this? Every single time I see the words line tangent, I always do this. That's my speed sheet definition. Will this help me? I don't know. It should. It's usually the roadmap of where we're going. So what are we asking for? There's a point P on the graph of f at which the line tangent, this thing right here, is perpendicular to the graph of g. Find the coordinates of point P. So So I don't know if this is going to be too helpful because I don't know what the x-coordinate is and I don't know what the y-coordinate is, but let's just go ahead and use this as a roadmap. So far, we know the slope. The slope is 1, which means up here the slope is 1. I don't have a feeling that we're going to be using it this way. What else do we know? If we know that the slope is 1, how is that going to help us? Well, we have an equation, don't we? We have an equation of f, and we know that the slope is 1. Can we somehow find where the slope is 1 on f? Shouldn't that help us, right? Because I have to have the same slope. I don't think this is going to help us, guys. So over here, I'm going to say that I need to find where f. So the question is, where is f? Or where does f have a? Oh, that's too big of an eraser. Where does f have a slope of 1? Question mark. So where does f prime of x equal to 1? Well, that is an equation. F is the square root of x. Therefore, just as a side note, I'm going to do some side work. If f of x is equal to the square root of x, then f prime of x, if I take the derivative, this is technically x to the 1/2. Taking the derivative means the 1/2 goes down in front. This is going to be 1/2 of x. And then this power goes down, and it's going to be to the negative 1/2, which is the same thing as 1 over 2. And then there's an x in the bottom, which is now to the power of 1/2, which is the same thing as 1 over 2 square root of x. So that is f prime of x. If that's f prime of x, what I'm really saying here is that 1 over 2 square root of x has to be equal to 1. That's what I just said here. F prime of x is equal to 1. This is f prime of x, which needs to be equal to 1. Now I'm going to solve again. I'm going to cross multiply, which means bring you up to this right side, and I'm going to get this new equation, which says 1 is equal to 2 square root of x. And then from here, I'm going to divide both sides by 2, move this 2 over here. When I divide both sides by 2, I get 1 over 2 is equal to the square root of x. And then finally, I'm going to square both sides, and I have run out of room officially. Do I need that? I mean, I said it out loud. Do I really need to write it? This is the point of how much work do you show in your answer key. I don't think I need that. This says that for me, and you can just watch the video if you get confused. All right, so keep going. And then down here, square both sides, and this is going to be 1 squared, which is just 1, and 2 squared, which is 4. Therefore, x is equal to 1/4, which is nice because I am looking for the x and y coordinates of point phi, and I have pi, p. What is this thing? P, and I know one of them. It's 1/4. Therefore, I'm looking for the y coordinate. So where's the y coordinate? You just plug in the x into the y. Look, I have the coordinate. I have this function f. F of x is equal to the square root of x. If I'm looking to find what happens when I plug in 1/4, what is f of 1/4? I just plug it in, and it's the square root of, you guess it, 1/4, which is the square root of 1 over the square root of 4, which is the same thing as 1 over 2, which is the y coordinate. That is the y coordinate. So technically, yeah, this didn't help us, but we did find the x coordinate was 1/4, and then we did find the y coordinate, which is 1/2. We did find that point, and that point. It was a roadmap, but it ended up not really helping us. I'm going to erase you. Sorry that we went on it wasn't really a false goose chase, but we got it. P is the coordinate 1/4, that was x, and the y coordinate is 1/2. Done and done. That was kind of a hard problem. And it feels like it's a review problem to me. Because really what we did was we found the slope, used the slope, knew that the slope had to be talking about this thing, found that thing, set it equal to the slope that we knew, and then found the x-coordinate, and then plugged the x-coordinate in. I mean, I don't know, I don't know what unit that was from, but it felt like it was a review. Anyway, number 5. Let R be the region in the first quadrant bounded by the x-axis. Find the area. Do you have a calculator this time? Yes! Here we go. All right, that's not perfect. There it goes, unacceptable. There we go. Integral to the left, integral to the right. That triangle is a triangle, but I don't know what height that is, so let's just plug it in, right? I need to find u. I found u, good. I found u, good. Okay, I just need u. So, calculator, how you doing? There you are. Let's make you skinny, clear. All right, so our functions are natural log of, that one has to be the natural log of x function. So this one is natural log of x, and this one is the other one, therefore it's 5 minus x. 5 minus x. How did you know that, Mr. Sindel? Natural log is a curved line. 5 minus x is a linear, aka straight line. All right, so it's clear, clear. First, we have a natural log of x. Secondly, we had a 5 minus x. Okay, so let's go ahead and our window, I'm going to make the exact same window here. So our x bounds from 0 to 5. So x bounds from 0 to 5. Our y bounds are going to be from 0 to about 2. So I'm going to say y bound, -1's fine, but I'll say 0. Come down here, clear, hit 2, and I'll just hit graph. I don't hit zoom 0. Yeah, looks about right. Just got scaled differently because I have a square calculator. I don't have this is a rectangular screen right there. My screen is that screen right there. So it all got compressed a little bit. All right, so find the area. I need to find at this point. You are second, hold on, clear out of stuff. You are second trace, and I'm going to do intersect, so option 5. My left bound 2, yep. Right bound is 5, sure, yep. And the intersection happens at, 3.693. 693. Okay, we have the x coordinate, we have the left bound. So the integral to the left is going to be integral between, not 0, be careful. This one is not 0. It starts here at 1. It goes from 1 to that 3.693. 1 to the 3.693 of our first function, which is the natural log of x function, technically dx, plus the integral of the right piece. The right piece is going to be that same bound of 3.693 to whatever our end x coordinate was. In this case, it's 5. So come back over here, 5, and then that function is 5 minus x. 5 minus x. Technically, all that needs to be in parentheses, multiplied by thickness dx, and then we just type it into the calculator. Clear, clear, clear. Second mode quit, and we're going to type in math 9 integral between 1 and 3.693 and natural log of x. Natural log of x. Okay, good. Plus math 9 integral between 3.693 all the way to 5 of our function 5 minus x, and go. 2.986. So I get 2.986. Nice. All right, moving on to part B. We still have a calculator though. All right, there is a, okay, it's the same type of thing. There's a point P on the graph of y equals natural log of x, which is tangent to the graph of that thing, which is perpendicular to the graph of that thing. Find the coordinates. All right, so the first thing that I'm seeing is that I have a typo, which I will fix in future years. That says perpendicular. The perpendicular, this word, if it was spelled correctly, means I take the opposite reciprocal of the slope that I'm talking about. I'm talking about this graph right here, and the slope of this graph is -1. So perpendicular would be, if I write down perp, then I can't misspell it. Maybe I can. Perpendicular would be slope of +1, because opposite means you make this into a negative, and then reciprocal means you flip. So negative flip of -1 is a +1. Cool beans. That means that is our slope, which means I need it to be the slope of the thing that I care about. What do I care about? I need to be tangent to this thing. That's kind of the key function. So this has to have a slope of this. That's what I want to say. So right now I have the function y equals natural log of x. I need to make it a slope. I need to take the derivative of natural log of x. So side note, I'm going to come over here and say, if I have y equals natural log of x, and I'm trying to take the derivative, y prime therefore will be, if you forgot log house, it's 1 over whatever your inner is. Don't forget your dinner. Okay, we didn't need dinner. Okay, so it's just 1 over x. Cool. This slope needs to be this slope. So I'm going to say now 1 over x needs to be equal to 1. Well, if I cross multiply and just bring this x over to the side by multiplying both sides by x, I get 1 is equal to x. Cool, we're halfway done because, again, I'm trying to find the coordinates of point P. The x coordinate of P is 1. I just need to find the y coordinate, and guess what? You just plug it into that function. So if I type, or write y is equal to natural log of x, and plug in my said one, this one gets plugged in right there. This is going to be y is equal to natural log of 1, which you should have memorized. Natural log of 1 or log of 1 or log base 3 of 1 is always equal to 0. So we have our x coordinate, we have our y coordinate. P is the coordinate point 1, comma 0. Done and done. A lot more fluid, a lot more natural than last time once we got some warm up on that one. Oh, and we are done with the homework. That concludes AP Calculus AB's Worksheet 11-1, Area Under Two Curves. Thanks for watching.